To our next session, we have a talk by Dr. Anoop Kunchukuttan on NLP at scale for Indian languages. I request Professor Anil to kindly introduce our speaker.
Yeah. Good afternoon. As Manish mentioned, this is the extension talk to that AI for Bharat. Dr. Anoop is a principal applied researcher in Microsoft Machine Translation team in Hyderabad, India, and co-lead of AI for Bharat at IIT Madras, advancing Indian language NLP. He's also an area chair of ACM rolling review in multilinguality and low resource NLP. His research focuses on multilingual learning, large language models, machine translation, and NLP for related languages. Dr. Anup has contributed to resources like Indic Trans, Indic LLM Suite, Airavat LLM, and the Indic NLP library, which support Indian language technologies. He completed his PhD at IIT Bombay in machine translation and transliteration. Yeah, over to you. Yeah, thank you.
Hello, everyone, and thanks for the kind introduction. I'm really happy to be here. I think since I started with my association with NLP at IIT Bombay, IIIT Hyderabad has also been a part of the journey. So really glad to be here, and congratulations to everyone involved in building this institution. And today, I think I'll talk about something that IIIT Hyderabad has been involved in, along with a lot of institutions in India. So, and alluding to how do we build NLP technologies at scale for Indian languages. So what do we mean by scalability? It means the ability to handle a growing amount of work within constrained or set resource limits, right? And what do we mean by that in this context? What we mean is the ability to address maybe a wide variety of languages, a wide variety of tasks, handle a range of requests, volume of requests, etc. So yeah. In this context, I'll focus on the number of languages and tasks for today. And I think it bears no saying that the challenge in India is the diversity of languages in terms of the number of languages, the number of language families, the scripts, and the fact that even though it's a language country with a large number of languages, it still is a country with amongst the highest, I mean, it's fragmented, yet each of those languages have such a huge speaker base that they warrant a high volume of usage, right? So, and within languages, dialects, registers, and many other phenomena to be handled. Coming to, say, use cases, we want to support, say, applications for social good, government services, for education, for, say, information dissemination, etc. Maybe just to enable people-to-people contacts among people speaking a wide variety of languages, be it culture, be it movies, etc. And surely business, economic goods, how do we enable good business, right? And to do all this, we need to build technologies that can be easily scaled and can be brought, can be easily enabled for a wide variety of languages. So how do we do that? So first of all, what are the challenges there, right? The challenge, as we have already alluded to, Mitesh spoke about it, that one of the primary challenges is data, right? So we lack data and data of different kinds, be it raw data, be it domain-specific data, data for training specific tasks and models. In terms of the size of the data that we have, how do we scale? And when it comes to that, then it also means labeling the data. So do we have at scale people the skill to do those annotations with a certain level of quality, right? So that's one part of the story. The other part of the story is running cost, deployment. So again, in a price-sensitive economy like India, if you want to run models, the model sizes should be constrained. Inference time and latency are, of course, always important for applications. We want to keep maintenance low. and to have the right developer tooling so that uh, building these NLP applications is easy, right? So that's another aspect of scalability. And finally, evaluation is a very important aspect. Now we are moving towards an era where we have more and more complex NLP applications, more subjective applications. And in that case, how do we evaluate these tasks? How do we solicit quality judgments? And not just quality solicit judgments, but also how do we get feedback for improvement, right? Many times you're just working on languages you just don't understand, right? So what is the right mechanism for doing that? So these are the kind of challenges that exist. I'll touch upon a few of these today, primarily from the data point of view. And this is the picture a few years back when we sort of started looking into scaling data. And this is sort of an illustrative example of the gap between English and say Hindi, which would be amongst our most resourced languages by far. So if you look at Wikipedia, English has around 6 million articles compared to Hindi, which is just about 150K articles. The same is the story with parallel corpora for machine translation, or if you want to look at NER corpora for doing name entity recognition, or if you want to do quest answering, squad data set is by far larger than anything that exists for Indian languages, right? So that's the challenge. And how do we approach this challenge of scalability? And my thesis here is this. Uh, that's been the attempt of NLP over the last 30, 40 years, and each generational change that has come about has tried to address this scalability challenge by making it, by kind of lowering the effort required and thereby enabling more work to be done. And if you look and more, and let me talk from the perspective of just number of languages, right? So we started with rule-based systems, and moving from rule-based systems to classical ML, the requirement for linguistic expertise, which is always at a premium, reduces. Moving from classical ML to deep learning, we can do away with feature engineering and associated tools for feature engineering. So every language would have to do its own post taggers and parsers and things like that. So that is one sort of evolution that's happened. The semantic representation helps. What deep learning really enabled and in for multilingualism is the fact that you can represent data from multiple languages into the same vector space, and then enable multilingual and zero shot kind of applications, right? Uh, Going ahead, pre-training LLMs have all added to that, reducing the data requirements. Uh, so, in very concrete terms, what do we do today, and what is the kind of approach that looks appropriate and what seems to be working, right? So today we are all work in this era of deep learning based NLP, and representation learning, as I said, has a lot of interesting things to contribute, which helps bring down the cost and the effort in terms of the uh, reduction of feature engineering, etc., that I just mentioned. Multilinguality is a critical component. It sort of helps to build language agnostic models, especially if you can have one language help the another. And so data requirements across languages amortized over these languages can reduce. Uh, Pre-trained language models have enabled us to sort of infuse a lot of world knowledge, linguistic knowledge upfront into the model, so that when developing certain task-specific models, the need for data kind of goes down. Then there is the whole notion of being able to gather and mine data from public sources, from the web, and etc., which is a good opportunity to sort of leverage and get data at scale for various kinds of problems. So we'll kind of walk through some of these things. So as an initial activity, what we found useful was just curating data. And this is an example from when we started working on machine translation. So all we did first was look at a lot of efforts the community has put in from various groups, gathering little amount of parallel data, putting it all together. And just doing that, I think, gave us around 12 million sentence pairs across 10 to 12 Indian languages that we were looking at that point. And that itself was able to help us build a MT model that was better than anything that was available in the public domain. So cataloging, organizing is a very useful activity. There are many examples of that across the globe. Opus, for those familiar with machine translation, is a very classic example. We have tried to put together an Indian NLP catalog where you can collaboratively submit and uh, edit resources available. And there are similar efforts on the Indonesian side. I recently came across GLOT 500 corpus, which I thought I should mention because it's an effort to collate language resources for 500,000 plus languages, and that looks pretty interesting. So that's of course the challenge in these curation efforts is that the effort to sort of make it easy to search, navigate, and maintain the catalog over time. But it's, I think, worth the effort and should be an ongoing effort. Uh, Now, the first activity to do is sort of to collect monolingual data at scale, which we invested in while building text corpora for Indian languages. And it's the story sort of evolved. We started with just building, uh, gathering, crawling web sources, collecting sentence level data, uh, to increasing our language coverage, increasing our uh, coverage for uh, more sources, which sort of resulted in Indicop V2. But eventually, I think with LLMs coming in, people have realized the need for one document level, large context, so as to be able to reason and understand a lot of knowledge. Plus the fact that you have to filter, curate data. And so uh, building a pipeline to do this, to get data from various modalities, be it text, be it PDFs, be it audio, and then to be able to filter it is a very important uh, infrastructure to be able to scale our NLP technologies. Because this corpus is kind of the basis for a lot of things, not just for training LLMs, but uh, it's a treasure trove for mining a lot of data sets. So be it translation corpora, transliteration corpora, named entity recognition corpora, everything. Many language generation data sets have just been mined based on monolingual data. So that's important, and this should over time evolve as more corpora comes in. This activity needs to be sort of continued, iterated, and uh, move towards collecting more corpora. It still probably doesn't go anywhere near the 10 trillion uh, uh, target that Mitesh mentioned, but whatever exists for Indian languages, that's an ongoing activity. Right. So that's about unlabeled data. And as I said, this is an example of uh, a very rich resource. And I'll talk about how we could mine labeled data from it. And I'll take the example of machine translation. So for machine translation, what we need is parallel corpora. And so we could mine at different levels of granularity, sentence level, document level. So we started with working on sentence level because that was what MT models were doing previously. And you could do some simple heuristic based mining. Some parallel websites and you use URL patterns to identify uh, websites and sentence and mine sentences from them. That's not sufficient, right? There's much more parallel content on the web. Can you be more ambitious and say, okay, I just give you millions of sentences in English and millions of sentences in Hindi, and can you figure out what are the parallel sentences? With multilingual embeddings and nearest neighborhood search at scale, we can do that. And with that, we were able to kind of mine up to 200 million sentence pairs across about 14 to 15 Indian languages. And this kind of exceeds any uh, human curated data that exists. And it's been a significant contributor to improving translation quality overall across all Indian languages. Of course, it's important to filter this data. There is noise. These mining systems are not perfect, but that's the way, the better the metrics get at identifying bad translations, the more cleaner our corpus gets and the better we can do. Uh, and these are a few more examples of what you can do with monolingual corpora. So we have mined, say, for example, headline generation datasets, summarization datasets, biography generation from Wikipedia. So if you have the Wikipedia info box, and then the first few lines of a Wikipedia article, it is a kind of table to text kind of data set that you could extract from such a model. So the possibilities are kind of immense. It's just creativity that limits what you could mine. Of course, after all the automated mining, we also there is a very important role for expert annotation as well, because that helps boost model quality, very high quality data, which I think is understood these days. Uh, if you build translation models on top, built on mind data and then fine tune it with human generated data, that gives a good boost in translation quality. And this applies not just to translation, but also many other applications powered by LLMs where high quality fine tuning data is very valued. So the role for experts and annotators lies there. Uh, and for some languages, for very low resource languages, this is probably the only way to collect data. There is no way of mining data for many of these languages. Uh, Now, when we want annotators to build, to create these data sets, again, we need a scalable way of doing it because this is a very subjective task. So we must put together very clear processes in place. And that's what we tried to do in terms of giving clear guidelines for translations to the extent possible, refining it over time and as we gathered experience, but also selecting the kind of sentences to translate so as to ensure it's diverse. Make sure you have quality checks on the source side before translation, quality checks on the translation itself to ensure the output quality. Uh, Along with that, it's also important to give productivity tools to translators so that their work is speeded up and we can make the maximum use of their efforts. So this could be in terms of, say, transliteration tools for Romanized input or draft translations being made available, glossary support being available through a very easy to use translation interface that you can see here. Right. Right. Okay, so far we talked about human data, either mined of the web or uh, curated in controlled environments. But increasingly, there is the trend towards using synthetic data for training. And I'll just use machine translation as an example. And machine translation has been doing this for quite a long time. For neural MT, it's standard practice to sort of use uh, monolingual data on the target side, translate it so as to create pseudo parallel corpus and get better language modeling, right? So, but increasingly, this is also being used for many other purposes. I mean, question answering data sets are being LLMs essentially use LLMs to create different kinds of task specific instruction tuning data, which you could use to distill and create smaller LLMs, right? So the important thing there is that you need to filter this kind of data so as to ensure that the quality is used good enough to make sure that the model can do the task it has to do without doing any hallucinations. Uh, Finally, a very important part of being able to scale to many languages is multilingual modeling. And I think now we take multilingual models for granted. It's a no-brainer for Indian languages whenever we're building any sort of models. These are typically multilingual models. Uh, the the benefits are obvious. I mean, with lesser data, we are able to generalize better, do well on low resource languages. In some cases, get good zero-shot performance with or very little training data for low resource languages, which is an important use case. But at the same time, multilingual models also from the deployment perspective improve scalability because you can have smaller models with the deployment footprint being smaller. You don't have to have a model for every language, say, but just one single model. Um, and one single model means easier maintenance. So from that perspective, also multilingual modeling is interesting. So this is one of the uh, biggest factors that has sort of helped to scale our current NLP models to multiple languages across tasks. Finally, of course, language model pre-training is a big uh, uh, advancement. Now, how has it helped? So it helps essentially by encoding a lot of knowledge and thus providing base features on top of which you can fine tune for certain tasks. Now, okay, what are the challenges if you want to use massive pre-trained models that already exist? Say, for example, XLMR or MBART or something. Can't you just repurpose them? Or even the modern LLMs like Llama 3. So, as Mitesh also sort of alluded to, there might be limited coverage for Indian languages. Tokenizer representation is an issue. Limited language coverage. They might not support all the languages, and therefore there is sort of a need to have certain, say, India-specific language models which can cater to these demands. But of course, the challenge, as we all already talked about, is compute. How do we have the compute to train models at that scale of data that we're talking about today? And also the fact that the models that are trained today are trained with a lot of English data, 10 trillion to 15 trillion for Llama 3. And the data there is valuable, the information there is valuable. Uh, Training from scratch, we will be losing all of that. Uh, or we need to kind of account for being able to train with the same amount of data, right? So is there a middle path worth exploring? Can we take some of these well-trained English models, adapt them for the languages, adapt their vocabularies for the languages we are interested in, while avoiding any catastrophic forgetting? So that's sort of the one possible option for LLMs in Indian languages to look at. And finally, machine translation is itself a big enabler for scalability. And I think we already talked about it. Both Hitesh and Ravi mentioned the use of translation as a vehicle for creating data. Uh, and it sort of, in many contexts, is just the scale at which English datasets exist. It would take a long time to translate, to create native datasets for it. Probably not possible. But if we can translate at scale, we can create large instruction tuning datasets for Indian languages, enabling instruction tuning. And this is particularly important for today's autoregressive decoder LLMs. Previously, when we were doing classification models, there used to be a fair amount of cross-lingual transfer. So you could still do cross-lingual transfer without having to translate, but that's not necessarily the case with decoder LLM. So that's important. I'll leave it with a final thought. We talked about translating training data, but what about evaluations? That's a very open question. Are machine translated benchmarks good? There is an increasing usage of these benchmarks, but there are studies that point out that quality issues do result from these kind of translated benchmarks. And they are probably only applicable even then as some sort of an indicative guide when the translation quality is reasonably good. On the flip side, there are also studies which sort of show that even human translated benchmarks for low resource languages are low quality. In fact, in some cases, the machine translated ones tend to be better. So there is judgment and caution to be exercised in both cases. So to summarize, what is the recipe for scalability that the community has discovered over the last few years? So it's train these large pre-trained models on huge amount of corpora in a multilingual way, mine data sets, and I would say today even synthesize data sets using LLMs, fine-tune using these data sets, and then create benchmarks for evaluations. Now, what are interesting directions going forward? So English LLMs is a reality, uh, trained on humongous amounts of data. So how do we make sure that we can do good cross-lingual transfer from English, other than basically having to translate everything from English into other languages? Are there good ways of doing it? Synthetic data generation, both for fine-tuning as well as preference data generation, uh, are other rich areas sort of to look at for scalability. And finally, evaluation. I mean, that's a very central challenge. How do we evaluate the ever increasing complex NLP tasks? And here, I think machine translation has some lessons to give, because I think machine translation sort of has a lead and has taken the lead in doing learned metrics, which correlate with human judgments and are increasingly showing to be doing well. LLM-based evaluations are starting to pop up, and how do they pop up for the multilingual scenario? We need to see, but those look like interesting directions to look at. So with that, I'll close my talk. Thanks.
Thank you, Dr. Anu, for the nice talk. Yeah. We'll take only one question due to interest of time.
Okay, Anoop, as usual, very contentful. Just wanted to tell you that the translation seems to be promising. This EMNLP, we have a paper on translation is Meet Doshi is the first.
Yeah, exactly.
And we show that the performance decreases only marginally,
Yeah.
0.84, 2.84, that kind of points. So I just wanted to make this comment.
Yeah, that's a valid point. I think increasingly, even for pre-training, like the use of empty data is promising. Yeah, it's probably only the scale of translation that needs to be done to do the training, and the resultant increase in training data for the LN is a concern.
Yeah, thank you, Dr. Anoop. I request Professor Vasu to.